All right, good afternoon. Today we're going to continue with polynomial division, and there'll be some parts in there that will get a little bit tedious, and part of the reason is that in your textbook, okay, the display can be kind of different in terms of the answers, and Alex can have his own bit of lingo in terms of how the answers or the outcomes are to be displayed. And for what we have in the case of polynomial division, okay, and okay, just for this reintroduction, okay, now I'm going to display f of x kind of like when we looked into the end behavior of the graph of a function, okay, and we have in the case of a polynomial, okay, so you have f of x, again we have is equal to, okay, like the leading term, again we have a of n, x to the n, so kind of like end behavior of the graph of a function. The leading term coefficient is a of n, and the degree of the function is defined by n. And we have subsequently, okay, so you have a of n minus 1 times x to the n minus 1. And we have plus a constant, which we're going to have represented, okay, by a naught. And for this polynomial, okay, whenever it is divided by, let's say, a first order binomial expression for this particular case, all right, there are two modes of polynomial division we can take. And now the first one, and we briefly looked into this, okay, and this is going to be for what we have in the case of the long division setup. Okay, so here for the long division setup, okay, so we have x minus c, and we have taking into the dividend. And once again, okay, for what we have in the case of x minus c, okay, so again, x minus c, okay, so this is going to be the divisor. And for what we have with the polynomial, okay, so we have f of x, okay, this is going to be the dividend. All right, now if I'm looking at where the divisor is going to be a first order binomial expression, okay, we have our long division setup given as such. Now, the other mode of polynomial division is going to be with synthetic division, and representing x minus c, and just going back to locating zeros. Say if the factor is x minus c, and I attain the 0 of x minus c, so this is going to be from x minus c is equal to 0, and so we're going to have that x is equal to c. And for the synthetic division setup, okay, the synthetic division setup is going to be, and just kind of taking the route here, so converting the binomial factor, okay, to the 0. So we have x minus c. So the synthetic division setup, okay, we're going to have boxed in or isolated to the left. Okay, we're going to have the 0 of x minus c, which is going to be c. And then we have going across this partition, we're going to have just coefficients of the polynomial. So we have a of n minus 1. So we have column headings that will be formed. Okay, and so we have going all the way out to a naught. All right, and now just taking what we have as examples. And I normally said this about midstream for the other classes, but what I'm going to do here, okay, to use synthetic division, division, okay, the divisor must be in the form of x minus c and let me just kind of just add a little term here, to use synthetic division directly. Okay, so you have the divisor must be in the form of x minus c, where x is of first order. Okay, so just kind of doing a little bit of categorizing. Okay, so if you have your divisor, and whether you can use synthetic division. Whether you can use this directly. Okay, so if your divisor, okay, so you have something like x minus 3, and because x is a first degree, you can use synthetic division directly. And if you have your divisor to be in the form of x plus 2, because x is a first degree, you can use synthetic division directly. But if I had something like x squared minus 5, and it's going to be because of the second degree that appears, and the answer is no. So again, so x is going to be of first order. So here x is a first order here, and x plus 2 is also a first order. But if I have a divisor like x squared or x cubed or even x to the 2/3 or x to the 1/2, because the power of x is not a first degree, I cannot use automatically synthetic division. Okay. Now, for what we have regarding polynomial division, okay, and we'll start out with a case where if we have, let's say, looking at it through the perspective of using long and synthetic division, and let's say that if I have 7x to the 4th plus 2x squared plus 1 is divided by x minus 1. Okay, now, all right, so you're going to have in the ratio. So if I wrote this as a ratio, so you have 7x to the 4th plus 2x squared plus 1. And again, we have all over x minus 1. Now, if I take the long division, okay, so for the long division, okay, so your divisor, okay, that is going to be at x minus 1 And for what we have here with this particular polynomial, that we have a fourth order. Okay, so you have 7x to the fourth. And notice we are missing a third order term. So I'm going to use a 0 placeholder. So you have 7x to the fourth plus 0x cubed. And I have plus 2x squared. Notice we are missing a first order x term, so I'm going to use 0, another 0 for placeholder purposes. And the dividend closes out with a constant. Okay, so just taking what we have with the long division. Okay, now again we have both sets of terms, the divisor and the dividend, are in descending degree order, and looking for the quotient. Now again, we're going to be looking at the higher or highest degree terms. Okay, so I have x from the divisor, 7x to the fourth from the dividend. Okay, so the first term, the quotient, will be from taking x into 7x to the fourth, or 7x to the fourth divided by x. So this is going to be 7x cubed. All right, and now just to kind of give you a visual. Now, if I just, in terms of what I'm going to do with 7x cubed, again, I'm going to multiply the divisor. So I have 7x cubed times the quantity of x minus 1. So I would have 7x to the fourth minus 7x cubed. And for this set of terms, okay, I'm going to have these lined up underneath, okay, the like terms that correspond from the dividend setup. Okay, so again, so I have 7x to the fourth minus 7x cubed. Now with synthetic division, okay, we're looking at row by row subtracting. And synthetic division, okay, is going to be a process of column by column addition. Okay, so we have in the leadoff, okay, so 7x to the fourth is going to cancel out. Then we have 0 minus negative 7x cubed. Okay, this is going to be addition. So you have 7x cubed. Now for the terms from the dividend that follow, they have not been touched yet. But as we go further into the long division, okay, those terms will likely be affected. All right, so I started off, okay, taking x into 7x to the fourth. Now, we had the leading term now is at 7x cubed, and taking x into 7x cubed. Okay, so this is going to be 7x squared. And distributing, so I have 7x squared times the quantity of x minus 1. So we're going to have 7x cubed minus 7x squared. And if I line up these terms, so I have 7x cubes line up, and we have minus 7x squared is lined up directly underneath the like term from the dividend remnant, which we have at 2x squared. And looking at taking what we have now. So we have the next phase. So we have, again, so we have going row by row with subtracting. So 7x cubed minus itself will go out. Then we've got 2x squared minus negative 7x squared. So this will translate to 2x squared plus 7x squared. So this will be 9x squared. And we have plus 0x plus 1. And then now we're taking x into 9x squared. Okay, so 9x squared divided by x. Okay, this will form the next term in the quotient, which will be 9x. Okay, so in terms of the appearance of the terms, so we have 9x squared minus 9x. Okay, so situating these terms underneath the like terms from what we have from the previous stage. So we have 9x squared and negative 9x. So I've lined up the square and linear terms in x. And looking at, once again, subtract, so we have 9x squared minus itself. Then we have 0 minus negative 9x, or 0 plus 9x, so we have 9x. Then we have plus 1 to be brought down, and then we have x into 9x. Okay, so this is going to be at 9. So 9 times the quantity of x minus 1, so we have 9x minus 9. And with this remaining round, with the long division, and subtracting once more. Okay, so you have 9x minus 9x. This will go out. Now we have 1 minus negative 9. So this is going to become 1 plus 9. Okay, so we have 10 left over. And I cannot take x directly into 10 since x is higher in degree than what I have with the constant value 10. And now, in looking at what we have now in the completion, now we have with the quotient, okay, so you have 7x cubed plus 7x squared plus 9x plus 9 and the number 10. Okay, so this is going to be the remainder. And just write this out in expanded form, okay? Because I know that there are some situations in ALEKS that will call for the expanded notation where you have displaying the quotient as well as the remainder over the divisor. So I'm just going to add in this detail. So for the ratio, okay, so this is going to be the quotient, again, which we have with this 4-term cubic polynomial. So you got this, and then we have plus the remainder 10. And we have all over x minus 1. Okay, so you got your quotient, and then you had the remainder attached, okay, over the divisor. So again, I kind of said something like this, I believe, already. If you have something like taking 3 into 10, 3 will go into 10 3 times with a remainder of 1. But if I were to write out what I have in mixed number terms, like 10 over 3, that would be like 3 and 1/3. Just like over here, you have that kind of reduction. We had the quotient, and then you had the fraction resulting from the remainder over the divisor. Okay. Now, for what we have for this same ratio, if I take what I have in terms of synthetic division, okay, so again, we have with this item, I should say, with the ratio. And again, before we had with the long division setup. So LD for long division. Again, we had x minus 1 into 7x to the fourth. And again, we had with the formation of zero placeholders, signifying that we had the exclusion of third order and first order terms in x in the dividend. Okay. All right, so this is your long division setup. Now if I take what I have here and put or translate what I have in this setup going to synthetic division. So I'm going to take, so I got a linear divisor with x minus 1. So x is a first degree, so I can translate this statement in terms of synthetic division. So representing x minus 1 is going to be its 0, which is going to be at x is equal to 1. And so just taking what we have with synthetic division. Okay, so representing again x minus 1, so we have the number 1, and then we have going across this partition. Okay, so you have like your a of n, x of n is 7x to the fourth. You have a of n minus 1, x of n minus 1, and then you have going all the way out to a naught. A naught is your constant, and in this particular case, that is going to be at 1. So you're not going to see the letter x in the synthetic division setup. Instead, you're going to have the 0 from the divisor and the coefficients representing the dividend. So we're going to have 7, and we're going to insert the zeros, signifying that there are missing places for particular degrees in the polynomial. So we have 7, 0, 2, 0, and 1. And for what we have in the case of synthetic division, okay, instead of doing the long row by row subtracting, we're going to do column by column addition. And some of the cases will feel like subtraction since we are going to be adding some occasional negative numbers. All right, so we have, again, so the 7 is in reference to 7x to the fourth. And what I'm going to do here to start out is that whatever the...
I don't know what you mean by.
Okay, so we have in the case of for 7x to the fourth, the leading term in the dividend is going to be the leading term in the quotient. So 7 is going to be brought down, and then we have 1 times 7 is 7. And after you take the product, now you're going to shift over to the next column and add. So you have 0 plus 7. Again, so this is going to be 7. And then we have 1 times 7. Again, it's going to be 7. Now, adding together, we have 2 plus 7 is 9. Now we have 1 times 9 is 9. Then we have next, we have 0 plus 9 is 9. And then we have 1 times 9 is 9. And this will be transported over. And we have 1 plus 9 comes out to 10. So again, for what we're going to have here, okay, so the leading number is going to be brought down. And you're going to multiply, so bring down 7, multiply by 1. Product is taken over, add again, multiply by 1, transport the product, then add in the third column, and you have that sum multiplied by 1, product is transported over, add once again, multiply by 1, transport, and we have the last column total. Okay, so this is going to be at 10. So you have that the remainder is equal to 10. Now, for these numbers that come in front of 10, those are going to be the coefficients of the quotients. Okay, now, when 7 was at the top, okay, this was in reference to 7x to the fourth. With it brought down, okay, the 7 that is at the front and at the bottom, okay, that is going to be representing term that is 1 degree less than the leading term in the dividend. So the leading term of the quotient is going to be 1 degree less than the leading term in the dividend. So this 7 is going to be at 7x cubed, and we have followed by plus 7x squared And then we have with the 9s. So we have plus 9x followed by plus 9. So in looking at comparing the two approaches, now whenever we had long division, okay, so again, we had the quotient, again, we still had 7x cubed plus 7x squared plus 9x plus 9, and we got it here in the synthetic division. And we have, in both cases, we come out to the very same remainder. Okay, now, there's going to be another case, and I don't think that the authors really stress this quite enough. Or maybe I'm just looking at the book in the wrong places. But if we have, let's say, another case, and we'll just look at this solution through synthetic division. Let's say that if we have let's say we have 2x to the 5th we have plus 4x cubed, and say we have all over x plus 2. Okay, now we're going to solve by using long division, by using synthetic division. Okay, but now for the long division setup, again, so for the long division setup, now your divisor is going to be at x plus 2 Now for what we have in the case of the dividend, so I have 2x to the 5th. Notice that the next term we have at 4x cubed, so I'm missing a fourth order term. So I'm going to use 0 as a placeholder. And I have 4x cubed. Okay, now if you notice, okay, I want the dividend to close out with a constant. So if you notice, I'm missing a second degree term and a first degree term in x, and also I'm missing a constant. So that means that in the follow through, I'm going to use 0 placeholders. So I have plus 0x squared plus 0x, again representing the missing constant. Okay, we have once again at 0. And again, we'll look at solving by synthetic division. And the reason I'm doing the long division setup is to make sure I'm not missing any terms, for any degrees that we have in x between the highest degree term and what we have in the constant. So for the synthetic division setup, again, I'm going to take the 0 of x plus 2. So if I have the x plus 2 is equal to 0, I'm going to have the x is equal to negative 2. And this will be carried over. So we have for synthetic division, so just take SD for synthetic division. So we're going to have in the display, so we have negative 2 to represent x plus 2. So negative 2 is the 0 of the binomial x plus 2. Now for the coefficients of the polynomial dividends, they have 2 for x to the 5th. 0 is for x to the 4th. And we have 4 for x cubed, and rounding out the rest, okay, with the negation, okay, or lack of presence of the square first order term and the constant. So I'm going to again just round out with the remaining 3 zeros. Okay. So just starting off Okay, so we have leading coefficient is 2, and I'm going to bring this down. Okay, so the dividend coefficient, first one, okay, is going to be brought down, then multiplied by the 0 to initiate the column by column adding that is involved in the synthetic division. Okay, so negative 2 times 2 is negative 4. And we have 0 plus negative 4 is negative 4. Then we have negative 2 times negative 4 is going to be a positive 8. And then we have 4 plus 8 is 12. Next, we have negative 2 times 12 is negative 24. And we have 0 plus negative 24 is minus 24. Next, we have negative 2 times negative 24 is going to be 48. And we have 0 plus 48 is 48. And then we have negative 2 times 48 is going to be at negative 96. And for the last column total, okay, we have negative 96. Okay, so for what we have here, the last column total, okay, so that is going to be the remainder. You can just use R for remainder. Remainder is going to be at negative 96. And for what we have in the terms that make up the quotients, again, I started out with 2. This is the one above we have in reference to 2x to the 5th. And now this 2, once it's brought down, we now have 2 referencing 2x to the 4th. And for the rest of the terms, we have negative 4, x cubed, and we have plus 12, x squared, and we have minus 24x, and then we have plus 48. All right. And in the case of the expanded notation, and the reason I'm going into this as well is I know that Alex is kind of big on the expanded notation with the quotient and the remainder over the divisor. So we have here, okay, so we got with the quotient, okay, so I have this set of terms, and again, just for the follow through in the case of the remainder. And so we have plus, and we have negative 96 all over the divisor, which we're going to have at x plus 2. All right, so another case of an expanded form, and this notation, okay, that I know that Alex is kind of big on this, especially separating the quotient and the remainder over the divisor. Okay, now for what we have in the case of the problems, okay, that we have on page 279, and we have for the case in number 12. Okay, and this is this is going to be a case where we're going to be looking into long division for right now. And there's another thing too I do want to mention about Alex. It seems a bit excessive, and you'll know what I mean in just a moment. Now we're going to have in number 12. Now we're going to have the divisor, which is going to be x plus 3. And for the dividend terms, so we have 3x to the 4th. And we have plus 17x cubed. And we have plus 20x squared. And we have minus 28x. And we have minus 48. Now with the nature of the divisor, okay, now you could do synthetic division on this one, okay, if the problem lets you kind of do it as such, okay. So we have a first order expression with x plus 3. Now again, for the first term of the quotient, we have x into 3x to the fourth. Okay, so this will go 3x cubed times. Okay, so, and just carrying out what we have here, if I envision, okay, so 3x cubed over x, that's going to be 3x to the fourth. And 3x cubed over 3, this will be 9x cubed. And this will be placed underneath the 17x cubed. Again, so we're back in line division mode. So line division, again, you're looking at row by row subtracting. So looking at subtracting, so we have 3x to the fourth is going to cancel. Now we got 17x cubed minus 9x cubed. So this will be 8x cubed. And again, we have the terms from 20x squared on down. Those have not been touched yet, but soon will be. Okay, so we have for the next part, okay, so I took x into 3x to the fourth. Now looking at taking x into 8x cubed. So we have 8x squared. And distributing, so 8x squared times x. Again, it's going to be 8x cubed. 8x squared times 3. So this is going to be 24x squared. And again, for the next round of subtracting, okay, so we have 8x cubed to go out. Now we have, in this case, sorry, we got 20x squared minus 24x squared. So this would be a negative 4x squared. And bringing down, we have minus 28x and minus 48. And then now we have x into negative 4x squared. So we have a negative 4x. And we have with the distribution. So we're going to have negative 4x squared and negative 4x over 3. So this will be negative 12x. And looking at subtracting, okay, so we have negative 4x squared, and then this will become plus 4x squared, so those will go out. Then we have negative 28x, and what's going to be plus 12x. So we're going to have a negative 16x minus 48. And then we have x into negative 16x, so this will go negative 16 times. And distributing, okay, so we have negative 16x. And negative 16 over 3 is going to be a negative 48. Okay, so we have with subtracting, okay, so you have negative 16x and what's going to be plus 16x. We got negative 48 plus 48. And guess what? We're going to have complete cancellation. So just for the results here, okay, now we have the quotient. Again, that is going to be 3x cubed plus 8x squared minus 4x minus 16. And again, we have for the remainder, okay, that is the last difference here, so that's going to be at 0. Now the part that I mean about the Alex, now in terms of taking what we have with this dividend. So we got 3x to the 4th plus 17x cubed plus 20x squared minus 28x minus 48 all over x plus 3. So just in taking what we have in the expanded notation, okay, so we have with the quotients. Again, so we have 3x cubed plus 8x squared minus 4x minus 16. Okay, now, in like a pencil and paper test, okay, if you had your answer as 3x cubed plus 8x squared minus 4x minus 16, that is a complete answer. In fact, as far as I'm concerned, that would be the complete answer. But with Alex, I'm going to mention this. So you have like the quotient and the way that it's programmed, the way that the software is set up. Okay, it's going to stress the remainder over the divisor, even if the remainder is 0. So you're looking at 0 over x plus 3. So just for, yeah, I know 0 over x plus 3 is negligible, say it would reduce to the quotient, but just this added bit here. To stress 0 over x plus 3. Okay, this is going to be just in reference to Alex. You just kind of get it to the whole thing to register. All right, now for what we have in the case of 16, now this is one, okay, where you cannot use synthetic division. Here, so we have x squared minus 3. And we have taking into the polynomial. Okay, so you have x to the 5th minus 2x to the 4th plus x cubed. Again, we have a missing square term. And we have minus 8x plus 18. Okay. I'm just going to stress, okay, notice you don't have x minus 3. Instead you have x squared minus 3. So because of this, you can't use synthetic division directly. Now, just for what we have in the case of long division. Okay, so the first term in the divisor, okay, we have x squared. Okay, and just like what I've done before, okay, leading term in the divisor, if I divide into the leading term in the polynomial dividend, so you have x squared into x to the 5th. Okay, so this is going to be x to the 3rd. And just kind of taking some of the work to the side here. And going back to this because there are going to be some terms skipped in the lineup. So if I take x cubed over x squared minus 3. So we have x to the 5th minus 3x cubed. And if I line these terms up with the like terms from the dividend, okay, so notice we have x to the 5th will be lined up. Guess what? Next term is not 4th order, but a cube. So we'll have minus 3x cubed. So I'm going to situate this underneath, not negative 2x to the 4th, but minus 3x cubed. So for what we're going to have here, okay, so we have just re-entering, okay, the subtraction and the synthetic and the long division process. Okay, so you have subtracting, so you have x to the 5th minus x to the 5th. This will go out. And notice negative 2x to the 4th doesn't have any like term directly underneath it. So I can just move this on down. Then we have next, we have x cubed minus negative 3x cubed. So this is going to be x cubed plus 3x cubed. So that's going to make 4x cubed. Okay, and the next terms came from 0x squared on down. Okay, so those have not been affected yet. Okay, yeah, I had 0x squared. Reason for this is that, okay, I do have the minus 8x. But again, you could, yeah, now for, if you had like, since you can have 0x in the divisor, you can do that as well. That's an option. You can do it that way. Yeah, so if you have like x squared plus 0x minus 3, you can do it that way as well. Okay, so we have, in the next case, sorry. Okay, so you have x squared and x to the 5th, so you have x cubed. Now, we have next, we have x squared into negative 2x to the 4th. So we'll have negative 2x to the 4th divided by x squared. So this will be minus 2x squared. And if I distribute, so you have like negative 2x squared distributed over x squared minus 3. Okay, so we have minus 2x to the 4th. And we have plus 6x squared and so just lining up, so you have negative 2x to the 4th. And then we have plus 6x squared, so pay attention to the degree here. So you have plus 6x squared. Okay, so if I subtract, so we have negative 2x to the 4th, and what's going to be plus 2x to the 4th. And I can bring down the 4x cubed. And we got 0x squared minus 6x squared. So we have a negative 6x squared. And we have minus 8x plus 18. Okay, then we have x squared into 4x cubed. Okay, so this is going to be at 4x. And again, just with the distributing. Okay, so we have 4x cubed minus 12x. So we got 4x cubed. Again, minus 12x. Okay, this can be placed under negative 8x. Okay, so in subtracting, okay, so 4x cubed goes out, and you're still going to have negative 6x squared, okay, to lead off in the next phase. Then we have negative 8x, and what's going to be plus 12x. So we have plus 4x, and we have plus 18. Okay, and then we have x squared into negative 6x squared. So this is going to be, looks like this is going to be the last term of the quotient. So you have negative 6x squared plus 18. Okay, so looking at subtracting, okay, so we have negative 6x squared plus 6x squared will go out. And we got 4x still. And now we're going to have 18 minus 18. This will go out. Now, I cannot take x squared directly into 4x because the degree we have here is too high for 4x. So it's going to turn out that for the remainder, we're not going to have just a number, but a variable term. Okay, so you have the remainder is equal to 4x. And as for the quotient, okay, that was the array of terms at the top, okay, that we had to be formed. All right, and so looking at once again just for the expanded notation. See if I can. Okay, so in expanding, again, Alex is big on this. Okay, so you have, so this ratio you're going to have equal to what we have in the quotient. Again, we have plus the remainder over the divisor. So you have x cubed minus 2x squared plus 4x minus 6. And this will be plus 4x. And we have all over x squared minus 3. And again, so this is going to be the expanded notation of what we have here. So x to the fifth minus 2x to the fourth plus x cubed minus 8x plus 18 over x squared minus 3 is equal to, again, this quotient plus this remainder over the divisor. All right. Now, for what we have in the case just the subsequent items, okay, and so we're at liberty, okay, to use synthetic division exclusively. And so here for the next portions, okay, so if I'm looking at using synthetic division, to find the quotient and remainder, And we have, in the case of number 20, okay, so we have a sum of cubes divided by x plus 4. And if you remember, okay, when we factor the sum of cubes, okay, we have like a binomial factor and a trinomial factor. And the binomial factor was the sum of the cubic roots of the cubes involved. So if you notice, it have like 64 is a cube of 4, x cubed is going to be the cube of x. So you're going to have complete divisibility on this one. So you're going to have the remainder to be 0. Okay, but just looking at what we have, say, for the long division setup. And the reason I'm going through this pathway is to make sure I'm not missing any degree terms. Okay, and if I am, again, I'm using 0 placeholders. Okay, so for the long division setup, again, so x plus 4 is the divisor, and x cubed plus 64 is going to be the dividend. Okay, so again, we have kind of a gap that exists between x cubed and 64. So we have a missing second order term, as well as a missing first order term. Okay, so we have plus 64. Okay, so this will be your long division setup. And if I translate this in terms of synthetic division, and again, I can use synthetic division since the divisor has x in first degree. Okay, so I have x plus 4 is equal to 0, and the 0 of this we have at negative 4. So now applying synthetic division. Okay, so plugging in, so we have the 0 value, negative 4, and this is going to be isolated, and then we have with the coefficients of the dividend. Okay, so x cubed, read this as 1x cubed, and then we have followed by 2 zeros. Okay, and this is referencing the void of x squared as well as x, and again we have with the number 64. Okay, so again, long division is row by row subtracting. Synthetic division is column by column addition. Okay, so you got the 1 at the front. I can bring this on down. And then we have negative 4 times 1 is negative 4. Then adding 0 and negative 4, we have a minus 4. Then we have negative 4 times negative 4 is going to be a positive 16. Then we have 0 plus 16 is 16. And negative 4 times 16 is negative 64. And 64 and negative 64, okay, will add up to 0. Okay, so again, the last column total is 0. So that is going to be the remainder. So the remainder is going to be at 0. Now for what we have in the case of the quotient, remember when we were factoring like the sum of cubes, like when we factored like x cubed plus 64, we had x plus 4 times what the quotient is going to be. So again, as 1 is brought down, that means that the degree goes from x to the third to x to the second. And then we have minus 4 times x. Then we have plus 16. Okay. So again, we have for the quotient, okay, so you have x squared minus 4x plus 16, and again, there is no remainder. And this would signify that x plus 4 times x squared minus 4x plus 16 would be equal to exactly x cubed plus 64. Now, for what we have in the case of number 24, okay, so we now have the divisor, okay, at x minus 2. And just again for the log division setup. So x minus 2 is the divisor, and we're taking into x to the fourth minus 5x cubed. Then we have plus 2x squared. Then we have minus x plus 20. Okay. And since the divisor is of first degree, again, I can just rewrite the setup in terms of synthetic division. So I have x minus 2 equal to 0, so we have x is equal to 2. So with synthetic division, okay, so I have 2 and with the coefficients of the dividend, so I have 1, negative 5, positive 2, negative 1, and positive 20. Okay, so again, the leading coefficient from the dividend I'm going to bring down and then begin the multiplying. Okay, so you have 2 times 1 is 2, so this will be shifted over to the next column. Then we have negative 5 plus 2 is negative 3. Then we have 2 times negative 3, which will be negative 6. Then we have 2 plus negative 6 is negative 4. And we have 2 times negative 4 is negative 8. Now we have negatives to add together. Negative 1 plus negative 8 is negative 9. And 2 times negative 9 is negative 18. And 20 plus negative 18 comes out to 2. So the last column total, okay, we have at 2. So the remainder is going to be at 2. And as for the quotient, okay, we have the variable terms that will have these items in front of the 2 as coefficients. So again, the 1 at the top was in reference to x to the fourth. And again, making 1 going from the leading coefficient in the dividend to that which we have in the dividend. Okay, a degree in x is given up, so this 1 will be in reference to like 1x cubed. And then we have followed by negative 3x squared. Then we have minus 4x. And then we have minus 9. And again, we had the remainder to be at 2. Now, for what we have in the case of number 30, okay, and just looking at this from a long division setup perspective, okay, so you got the divisor, okay, which is at x minus 3. And we have taken into, so we have 2x squared plus x minus 21. So we don't have any missing degree terms. And since the divisor is x minus 3, since the x term is linear or first degree, I can take synthetic division once again. So we have x minus 3 is equal to 0, so we have x is equal to 3. And we have with synthetic division, okay, so we have 3 Again, isolating 3, and we have with the other numbers, those are the coefficients where we're going to have 2, then 1, and finally negative 21. Okay, so bring down 20, maybe that bring down the 2. Then we have 3 times 2 is 6. Okay, then with the column addition, say 1 plus 6 is 7. Then we have 3 times 7 is 21. So I'll bring the 21 over. And we have negative 21 plus 21 is 0. Okay, so we have no remainder. So this signals that x minus 3 will go completely into the trinomial 2x squared plus x minus 21. So we have from here, okay, we're going to have that the remainder is equal to 0, and we have with the 2 and the 7 in front of the remainder. Again, this 2 represents 2x squared. Now that 2 is brought down, the degree in x goes down by 1. So this 2 will be in reference to 2x, and the quotient is going to be 2x plus 7. Now, for what we have in the case of 34, and now fortunately we're able to use long division and synthetic division. And if I had to use long division exclusively, this would be a rather, well, it would take up quite a bit of space. Here we have for the long division setup, again, so I have x minus 2 for the divisor. And the dividend, okay, so you have 2x to the 5th plus 13x to the 4th. I have minus 3x cubed. And I have minus 58x squared. And I have minus 20x. And I have plus 24. Okay, so for what I have here, so we have x minus 2. If I just attain the 0 from this and use that in the synthetic division setup, okay, so I have 2. Again, drawing out the coefficients from the dividend, so I have 2, 13, negative 3, negative 58, negative 20, and again we have it 24. Okay, so again, leading coefficient is 2, so this will be brought down. Then we have 2 times 2 is 4. Then we have with initiating the addition, so we have 13 plus 4 is 17. 2 times 17 is 34. Negative 3 plus 34. Okay, so this is going to be 31. And we have next 2 times 31 is 62. Negative 58 plus 62 is going to be 4. And we have 2 times 4 is 8. Negative 20 plus 8 is going to become negative 12. And 2 times negative 12 is negative 24. And 24 plus negative 24 is 0. Okay, so we have another case. All right, so where the remainder is going to be equal to 0. All right. And again, if I were to perform long division on this one, performing row by row, subtracting, quite a bit of space to be taken up. And where you can use synthetic division, you're not using up all that much space. And so the remainder is 0. And as for what we have in the quotient, so we're transitioning from 2x to the 5th down to 2x to the 4th. And for the numbers that follow, okay, we have plus 17 x to the 3rd. Then we have plus 31 x to the 2nd. And then we have plus 4x. And then we have minus 12. All right. So we have this quotient, and again we have complete divisibility since the remainder is 0. So like x minus 2 times the quotient, it would come out exactly to this fifth order polynomial. Okay. And now there's a theorem that's going to follow concerning divisibility, and there are a couple of items here. I'm just going to introduce the first part. Okay, and this is going to be what we have with the remainder theorem. And we have with the remainder theorem. Okay, so if we have a polynomial f of x so if f of x is a polynomial divided by divided by x minus c, then the remainder will be f of c. Okay. And let me give you just kind of provide a slight degree of separation, okay, between what we have done so far. Well, let's say that if you have if you're looking at determining the remainder of x squared plus 5x plus 4 divided by x plus 2. Okay. Now, you can perform synthetic division. And I'm just going to mention now for the long division setup. Again, so we have x plus 2 into x squared plus 5x plus 4, and just translating what we have in terms of synthetic division. So we have x plus 2 is equal to 0, and we have the x is equal to negative 2, and just relaying this to the synthetic division setup and follow through. So we got negative 2, okay, so we have 1 for x squared, 5 for 5x, and 4 for the constant. So looking at what we have here, so the leading coefficient 1 is going to be brought down. Negative 2 times 1 is negative 2. 5 plus negative 2 is 3. Negative 2 times 3 is negative 6. And 4 plus negative 6 is going to be at negative 2. So here, okay, so we had the remainder is equal to negative 2. Now if I take, like, say just these components, and I put this in terms of the remainder theorem. Okay, so we have, again, so we have f of x is equal to x squared plus 5x plus 4. Okay, and now in the case of division, when divided by x plus 2, and I'm just going to stress again, so we have x plus 2 x plus 2 is equal to 0. So you have that x is equal to negative 2. And where that f of c comes in, you're going to have that x is equal to c is equal to negative 2. And with the remainder theorem. Okay, so the remainder is equal to f of c. Well, what is c? C is the 0 of x plus 2. So that is going to be f of negative 2. And what is going to be f of negative 2? Well, we go back to the original function. It's kind of referencing what we have here. So you have negative 2 squared plus 5 times negative 2 plus 4. And we're just about there. Okay, so negative 2 squared is 4. 5 times negative 2 is negative 10 plus 4. And guess what? 4 minus 10 is negative 6. Negative 6 plus 4 is negative 2. And guess what? So you got negative 2. And regardless of the approach you take, okay, these end up being the same. So if you have a linear divisor, the remainder, using the remainder theorem, is going to be that function value at the 0 of that divisor. Okay.